our commencement time now, and thank you for joining. So we go straight to the point we left off the last session, and we build on that. So we've been diving deep. We've been diving deep into SQL, which is structured query language, and we've been taking quite a number of giant steps into the world of coding gradually. So even though we are still using a relatively familiar coding language to human language, this is more like helping to build our foundation and strengthening our understanding vis-a-vis how to play around with codes and extract some data out of the database. And in this case, it is the structured query language, which is the universal language for extracting information out of relational database. As said or mentioned in previous sessions, relational database is a very, very widely used, globally used database system that almost every organizations have it, and having the ability to be able to query out some data and analyze depending on what level of permission and what level of data familiarization your role is, it is a very important skill one must include in his or her toolbox as you carry out your day-to-day activities at work, even off work, it could be for some personal use too. This sharpens your understanding and gets you better. So, still on our curriculum, and here we have we've completed module 1, 2, 3, 4, 5, and we are almost getting done with 6. 6 is essentially dedicated to structured query language, which we've been dealing with for about 3 to 4 sessions now. And I'm sure in another one session today, we may have been able to cover completely all what is required for us under module 6. Then we go to module 7, which is technically almost um, the last module, where we'll be taking up another tool. This case, or this time around, it will be a visualization tool. So we've taken Excel extensively. We dealt with Excel, did a number of stuffs under Excel, and we moved to statistics. Then we land on structured query language. So all of these have been taken care of in the first 5 modules, the Excel and the statistics. Now from 6, we are dealing with structured query language. Module 6. Yeah. So module 6 is already introducing us to relational databases and structured query language. And we've also covered quite a large amount of information under that. So you could take advantage of the recorded sections for the things we've already covered under that. Then still on module 7, we just dwell a bit more on structured query language. Then by module 8, we move to what we call a visualization tool. This time around, it is Tableau. We another very similar visualization tool to Tableau is Power BI, which is the product of Microsoft's um, uh, corporation, as it were. So after that, then we go into some ethics and bias, then do 1 or 2 projects. Then that gives us a very comprehensive curriculum we can always refer to back and forth. So this is the curriculum, and we are now implementing it one step at a time, one module at a time. So having done that, we've equally gotten to this side, And that is okay. So by last session we were here, and we will kick off from here today. So we've dealt with a few um, elementary commands and codes in structured query language. Then today we want to see a few, what will I call it now? Some healthy practices, which I also call best practices in SQL queries. So, what are the things we are supposed to make sure we we make to be part of our culture while writing code? They are all standard professional practices, and it makes you look well organized and well coordinated if you, from this beginning stage, imbibe all of these practices as a must in the way you carry out your SQL queries. So it is important we uh, specify what these are and what their importance also are in what we do. So number one is to ensure you pay close attention to case. Case means, or case in this sense, mean either it is a lower case or a upper case. For instance, in this simple SQL statement written here, the most common SQL statement is used, which is select. And now we are saying select, and a column name is referred to here. So the column name in this sense is called product name. So you are telling the database to select for you this column in the table, and the column name is product name. Then you go ahead to further specify what the table, from which table the application should select this column from. In this case, the table name is called sales table. Now, just look at the structure, and that is exactly what this point is trying to tell us, paying close attention to the case. You see that deliberately some uh, portion of this statement are deliberately written in uppercase, while some others are written in lowercase, and that is deliberate. If you write everything in lowercase or you write everything in uppercase, the statement or the command or the code will still run fine positively, because the application understands it. And this is largely because SQL is not case sensitive. SQL is not case sensitive. If you write your code or command either in uppercase or lowercase, it will still run it and gives you the answer. But for legibility and readability, the ease of people being able to follow through the sequence and logical arrangement in your code, it is important to differentiate regular words referring to attributes. Attribute in this sense are the names we give to columns or some variables you want to call. It is good you differentiate what case those ones are written from the case with which you write keywords. There are keywords in SQL, and those keywords are what we call SQL uh, inherent commands. They are the set of words that are known to SQL, and the moment you invoke those words, you have already triggered an action inside SQL, and SQL understands it and is ready to carry out that instruction. So, for instance, the moment you type the word select in SQL, the application is ready to start reading around what next you want to supply after that select. So the moment I type this select and put product name, the SQL understands that it needs to go and look for a column called product name. It's awaiting you to now write or specify the table name. The moment you have specified the table name, the job is already done. It goes straight to that table, pick this column, and give you the output straight away. So for legibility and readability, is good to uh, just a good practice that most, or maybe all professionals, I would say, who are using SQLs have adapted to, is to ensure that those keywords are written in uppercase while every other thing is written in lowercase. So, and that is to easily help identify anywhere there are issues, or when there are red underlining, you will see whether it is the words written in uppercase that are underlined. So you know it is the misuse of the commands of SQL, and that is easy to quickly correct as it is. So, but if one does not do that, it doesn't mean the code will not run. It will still run and it will be executed fine. But if a layman is reading, or somebody else is reading and does not have enough attention span, some things will be missing while they are reading through. So it's always good to bring up a differentiation between keywords and regular words. So regular words in this case are words used to describe columns or the names of columns, so what we call column headers. And for instance, we are querying out a particular column whose name is product name. That is the name of the column. So we don't necessarily need to put that in any special case. It can remain in a lower case, while all SQL command or SQL statements can maintain uppercase. And that's a good practice. Second good practice is to also always ensure that spaces are introduced to separate keywords from attributes, or keywords from variables, or keywords from some sort of parameters. So for instance, select, and then I want to say select all. We all know that select all simply means star. This star you are seeing represent all in SQL. The moment you want to select the entire columns in the table, you don't want to start listing them one by one. Just like I have listed column, maybe the column I want here. There are several other columns in that particular table called sales, but I just went ahead to specify one. Because it is one, I can choose to write the name. But if it is all of them, all the column names I want to specify, how will I begin to write all of them one by one? It will just litter around the entire code and it will make it look tidy. So instead of listing all of them, there is a shortcut to do that, which SQL understands, and is just to use star. So the moment I write select star, SQL understand that I want it to select all the columns. And carefully see how it is written here. Select space star. That's a good practice. But if you go ahead and use select without any space between select and star, it will still run, but it doesn't look tidy. So all what you're trying to do now is just to um, highlight the fact that there are best practices that makes things look easier, look more tidy, and more professional, where if you for any reason have to share your file with people and some more advanced people, they will understand, okay, this person knows what the best practices are, and you write things in a way that makes it easy for you yourself to read and for other people to also follow should they need to check your codes or see some of the statements you have written. So that is the second best practice. Now, what is the third best practice? Is called the use of quotes. In this case, we have double quotes and we have single quotes. But for this particular best practice, we rather use single quotes. So there are many types of data. We have dealt with this in previous session. We spoke about data types that are called floats. These are uh, um, decimal numbers. So you can see some numbers raised here. I don't want to call, I was being tempted to say integers. So they are not integer, they are just numbers, but they are in decimal. So the right professional name, or technical name rather, is what we call floats. So there are data types that we call floats, and there are data types that we call integers, And of course, there are also data type that we call strings. So, and strings generally are sets of are text related data. They are not necessarily numbers. In fact, they are not numbers, they are texts. So when you are to use text, and more often than not, the name or the name of columns or names for tables or even names for databases are written using strings. And when you need to query or extract such names, there is a standard rule you must follow. So in this case, you are to put it in a single quote just to further make it more readable and to inform SQL that it is just a special set of characters that you need to take note of. So it's referring to something. So it will not take it as a regular element of a statement you are just writing. So it means you are referring to something that you expect it to go into the database or table to look for, then return it back to you in the response is going to pull out. And also, it's not necessarily just only letters. It could be a combination of letters and some very very will I call it unusual number, or we call it, we can say combination of numbers and some notations in numbers generally. So it could contain a few numbers and just also have some mathematical signs. It could have some asterisks. It could have um, some maybe it could have something called a star. It could have a comma included in it. It could have some very funny set of notation around that. It is also still a string, like an example I wrote here. So one could be just completely pure text, like I've written here. This is an example of string. Yes, those are just combination of texts. Then it could also be some characters, some strange characters or foreign characters. You can see brackets, numbers, then hyphen, and what have you. So those are also considered as strings. So when they are being introduced or you want your code to include them, one of the best rule of thumb is to ensure you introduce them using a single quote to bring them up. The reason a single quote is advised is because SQL sees the use of double quote for a different function entirely. So in order not to confuse SQL, it is good to just maintain a single quote. Okay, what is another best practice in SQL? Yes, another one is the use of aliases. Yeah, and in using aliases, you are just trying to make your queries or your commands as readable as possible. For some set of data, when they come up with the data set conceptualization, the way the column headers were written are just they could have just been written using some combination of letters that was only understandable to the person that coined or conceptualized them in the first place. But because data is now going beyond that person that was instrumental to the nomenclature in the first instance, it is good to ensure that your column headers or the name of your columns are as easy to understand as much as possible for anybody at all. The person doesn't need to be technically oriented to understand what a column stands for. What are the data in this column? What are they talking about? So if you use something that is not conventional or something not easy for people to familiarize with, then they may not be able to understand what the data in that column is about. And it could be needed in some sort of analysis when you are figuring out, okay, I need to carry out an analysis. Which of these columns will best be suited or will best be included in the equation I need to write? Or if you need to do a calculated column that is not even existing originally in the data set. So you just want to use part of the existing columns in the data sets to get an answer to a question. Then you want to create another column, but that new column you want to create cannot just fly in the air. It will have to do with a combination of one or two of the existing column, either multiplying themselves in one way or the other to give you a picture of the new thing you want, which can now better inform you as to if this is now answering the question I have or that I have got concerning this project or not. So in such situations where you now see that the existing column name is not easily lending itself for understanding or to understanding, then you can easily rename it. I will demonstrate it when we get back into the SQL environment after this. So we can change that column name, and to change it is just to use the SQL statement called has. So you go ahead and tell SQL to select that column name. For instance, in this example, the column name of a particular table is PLOC. That does not really mean anything to an average mind. Block or PLOC or what exactly, okay, what does that mean? So without somebody who wrote it telling you, okay, I mean, or I shorten it to be this, and this is what I shorten to be this, you may not necessarily easily understand. It should not be a guesswork. And there is no need for any guesswork when it comes to dealing with data. Everything is factual and following scientific principles and rules. So it has to be laid bare. So if you come across such situation, best practice is to change that column name into something more understandable, that when somebody sees, okay, this product, for instance, the last one we did was the column name is product name, meaning that in that column, all the names you are seeing there are product name. Everybody understands that. But in this case, a column is named block. An average person does not necessarily have to, I'm going to understand that unless the person who coined it say, okay, what I meant by block is this. So in order to unravel that and make it clearer, you can change it. And to change it, the statement you have to use is has. So you tell SQL to go and look for that particular existing name that is not easily understandable, select it. For instance, I said select block, then make sure you now change it to something I want. Now, in this case, the block actually means patient location. Who on earth will have understood that that P stands for patient? Because P could have could have stood for anything in the world that starts with P. It could have meant party. It could have meant people. It could have meant anything that begins with P. So that is why it is a good practice to ensure that your column header name is as crystal clear as possible so that an average person going through the data understands what each of the columns stands for. And when they need to fetch out information or extract instruction from the data set, they know which column is actually applicable or readily useful to answer such question you want the entire data set to answer. Okay, we still have one or two more. Yes. What other point of best practices do we have? Yes, it is also good to ensure we use indentations, and as much as possible, use a fresh line for every fresh or new SQL command. For instance, see this example I gave here. I'm telling SQL to select all from, meaning that select all columns from a table called students. And I gave further condition. I have told you to select all the columns. Yes, that's quite right. So go through all the entire column from that table. But now go ahead and streamline yourself to the students whose age or the students whose individual age is greater than 11. Then further go ahead to order that return or your output. Order it simply means arrange it by grade. What it means is that there is another column in that table called students that is called grade. So the output you are going to give me based on the instruction I've passed to you, I arrange them based on a column called grade. So go to a column called grades. There are numbers there. Arrange those number in ascending order. That's the meaning of this ASC. It means ascending. Arrange it in ascending order. Then don't give me all of the students that fall into that category. Just give me 5 of it. That's the meaning of limit 5. So that appears to just be a long writing horizontally that way. And if somebody who is not an advanced user of SQL, they may find it a bit hard to follow through. But if it is written with indentation included, for instance, that select all could stand on a separate line by itself, as now written here for legibility sake. Don't forget when it was written up here, there is no difference between the keywords and the attributes or parameters and variables. All of them are written in lower cases, which is not a best practice. So to correct that, you need to put keywords in uppercase, then you can write every other ones in lowercase to differentiate between the the words that SQL understands as codes and function, or that trigger something in Excel, I mean in SQL, and what other information you're now supplying that those particular keywords you act on. So including indentation, putting SQL commands in fresh lines makes your code writing very, very mature, makes it look tidy, makes it look very professional. It encourages readability, and it also encourages legibility. So what we wrote up here could have just been written this way as it is written down here, which is much more standard. Select all, next line from student, next line, not just all students whose ages are greater than 11, then go ahead and arrange them. I don't just want you to give all of them to me without any form of order. I want you to order it, meaning I want you to arrange it. Now, you are going to arrange it. Don't use the column called age again. Go to column called grade. Use the number there to do the arrangements. Arrange in ascending order, meaning from smallest to biggest, or from smallest to the largest. That is the ascending order. Then don't bother give me the entire output. Just give me the first 10, and that's fine. It understands it. So another best practice that is essential to be put in mind is you could have written your codes, and you could have taken time to deeply reason about the code you wrote, and some understanding actually led to that code writing. So because it is possible to forget a few things that led to that code, because different situation, different critical problems requires different reasoning and different brainstorming that bets code writing in the first place. So all of those reasonings and technicalities behind the reasonings, you may not readily recall them after that moment. So when you encounter such unusual complex situation and you have successfully written some codes, it is a best practice to put a narration beside some of the codes that you have written, such that when you need to revisit that code, you will understand why you wrote the code in the first place and what you wanted to achieve, or what you wanted the code to achieve. So even if you are being tempted to change the code, you will change it in line with what you wanted to achieve originally. That's one reason. Second reason is that some other people will see the codes and they will not understand why you wrote some other lines of the codes. They are at a loss as to the brain behind that particular part of the code. But when you put narration beside the code, reading that narration gives them more insight into what was the reason that bets the codes in the first place. So that's what we call addition of comments. where it might be necessary or useful in your code. And for SQL, for instance, in Python, when we want to do this kind of narration, you want to write some note beside codes. Because the platform or environment you are using is sensitive, you cannot immediately start writing those narration or comments beside it. The application will be thinking you want to add it to the code you have written. So you must first give some indication. In this case, in Python, I know you have to put an hash sign. The moment you put hash sign, the Python application knows that the next set of writings you are putting after hash sign, they are not code. They have nothing to do with the query or the code you are writing. It is just a narration or a comment. So it will not regard it. In fact, it will color it differently entirely. That's in Python. But in SQL, the moment you want to write a narration or comments, you put double dash, just as I've done here. So the moment you have put double dash, the application understand that, okay, you just want to put extra information for comment sake so that people can understand why the code was written in the first place. So those are the set of very, very important best practices that we must always put in mind while writing code in SQL. We have put them in practice severally from the different SQL statements we have written thus far, but it is very, very instructive to go ahead and highlight them this way that I have highlighted them. So back to SQL environment, let's see a couple of things we can do and how do we explain a few things around those best practices that I have discussed so far. Okay, so where am I? I've told us where to start from when you first land in your SQL environment. You want to know what database you are using, and that is very important. So I like that and execute that. It brings out your database for you this way. Okay, you can see, okay, these are the set of database available in this server. Okay, which of them am I using? Or before that, let me also see um yes, I need to pick my database first. Then is within my database, I can now ask it to give me the available table. All right. So go ahead and use school underscore demo. So that's the name of your database. Then you put your semicolon to end it. Do it this way, execute that. So SQL has already got itself prepared to use this database going forward. So everything I'm now doing on this is beginning to put it under school underscore demo. So, all right, I want to tell it to give me the tables under this database. Can I see what those tables are? So it gives me this way. So it's telling me that I have 3 distinct tables created thus far under this database, and they are named. One is shapes, one is called students, one is called teachers. So I'm just doing this just to refresh our mind again. So I can quickly run through the tables and I just say, okay, select all by using this sign from. Now I need to name the table. Let me start from the last one. Select all from teachers. So it asks that I run this code, it brings everything in that table for me. So this is the table named teachers. And these are the columns available in that table. We have the name of the teacher, we have the years of experience, and we have the designation of the teacher. Okay. I can equally say that let me just copy this to be very fast. Drop here. Then I bring this up. What other table name do I want now? I can say students. I have students. Yep. So I run this. It gives me the table called students. It has name, it has age, it has course number. Okay. I can equally copy this, or instead of copying it, I can just change this and rerun it. So I have another table called shapes. Yep. So I will just do it this way and run it. This is another table entirely. So these are very fast and simple way to quickly run around your table and see what is in there. Okay, what do I want to do? What else do I want to pick up in this now? I can say a few things. So for instance, I can say, okay, I want you to do something for me. Select I can say select a column in this table, and that column is called shape. Yep. Can say select shape for me. Okay. After selecting shape, what else do I want it to do? I can say, okay, um, find the average. Give me the average of which column now? I can use a slug. Yep. Is that correct? Okay. Let it give me this first. Yes. Select shapes from shapes. Yep. Yeah, that is ended. It will give me this way as it is. So I can also say um don't remove it. Okay. I can also say select shape. Okay. Give me the average of the average of what now? Let me just pick this one. S log. Then I need to go further to mention where that should be gotten from. Um our table is name shapes. Yeah. So I can do it this way. Let me see the response. Select shape, average shape, yeah, error, integrated query. Oh, okay. I was using the command, there was something still remaining. So you can group it by, um, you can still group by shape. Yep, select shape, average it this way, group by this. So let me bring the from here. Want me to relocate the from shape. Yeah, group by that. Okay. Let me view my table again to see the column I wanted to group by. Select all from shapes. Yes, so which column do I want it to group by now? Okay, so I can say okay. So I can say select from, yep, select from shapes. So inside it, you select the column called shape itself. So select shape, and this time around, we are trying to identify the column called slog. So here to this column, I assume it to be maybe the X location, which means the horizontal axis, because it's talking about shapes, and it could be two-dimensional shapes or three-dimensional shapes. But here, I think it's two because you're having X log and Y log in that main table for shapes. So select shapes, then I want to have the average. Average is a function. I want to have the average of all the figures in that particular column called X log. So, and it should group them by shape. You can see I've specified group it by shape. So if you go back into the table, there is a column called, for shape, where all sort of shapes are listed. So from this output, it shows that we have 5 different shapes on that table. And they are circle, square, star, heart, and squirrel as it is written, even though it was a mistake writing squirrel here. This person wanted, the person that imputed the data actually wanted to write square because it was not written as exactly as the other square was written, it considered it as a different shape entirely. But that's not exactly our goal. Our goal is to be able to see how we can group different things in the data we have got and make as many calculations as possible on that data and getting a new column. For instance, in the original data, there is a column called shape, and the column is right here. And that's exactly what I instructed it to use to group it by. But you will also notice that in the original data, there is no column called average, the average value for the X log. We only have X log. But now probably a question needed to be answered by the data. So you have to use what we call calculated column. So in this case, this is a calculated column because it's not an existing column. So I have to calculate it out from the existing one to give answer to the question we are trying to ask. And that's how we can easily play around the different operations and operators, mathematical operators in SQL. I can as well say instead of finding average of those S column, I can tell it to find, um, give me the sum. So I can change that average to sum function, and it should be able to give me what the answer is. So select shapes, sum X log. Let's see what it has. Do you recognize some? Um, I need to put, yes, some, or better still, I can just change back to average. Let's see, Y log, which is another column entirely. So copy that. So this is the same average calculation for y log. I don't know why it's not recognizing sum, but let's still try the average for another column, which is exactly what we are having here. What other column does this table have? Select all from shapes. Yeah, the entire table is having color dots, s log, y log, scale. Yeah, fantastic. So I can go further to say after it has selected this, let's see if you can further instruct it to order this same arrangement. So group by shape. After you have grouped it by shape, yep, then let's order it by something else. So order by, which other column can we order it by? Let's order it by dots. In this case, yes, order by dots. And that order, what do we want it to follow? Do you want it to follow descending order? Yep. For descending order, then do we want it to give us the entire 16 items on the table? Let's choose 10. Let's just put limits, and the limit should be 10. Close the code statement, go up again to this side, all of these. Yeah. So now it's giving us this output -4, -120, 102. But I wanted it to be 10. 1, 2, 3, 4, 5. Maybe it doesn't have entries that fall into these categories that are up to this. Okay. You will confirm now. Let me specify something smaller. This is how to play around. Select, select, select. Can you see? So I requested 10 before, and the output I got was 5. And that shows to me that, okay, probably the number of items in that table that falls into the different conditions I specified in the codes were not up to 10. That was why it gave me 5 as outputs. To confirm that, I now specify 4. Okay, give me 4. And you can see the output is now 4. So if I return it back to 5, now can return this back to 5, then run the code again this way, it will give me that 5. 1, 2, 3, 4, 5. Then if I just to further check to be sure that okay, it wasn't that the instruction for 10 was not correct, it was correct, but the available number of items in that table that falls into the category of the conditions this code has specified, they were not up to 10. So it just gave me the 5. Okay, I can say give me 3. Then I'll rerun this and see what I have. So select shape, average, y log from shapes. Go ahead and group it by a column called shape, not shapes. These are around. The name of the table is shapes. The name of the column is shape. Then now order the entire thing using another column called dots and give me that arrangement in descending order. Limit it to just 3 number of outputs. That's exactly all what we have told it to do. Copy this back, run it. Now I have my 3 items I've specified in this place. So these are ways you can easily bring as many instructions, extract as many informations as possible from your data. So let's see again, what else can I do? Select all. from, let me check another table now, students. So yes, I have students here now. This is students table. What can I bring out from here? A bit different from this usual select showing us the entire table. So select everything from students. Let's say where um yes, age where age is greater, let's say where age is greater than 20. Let's see what SQL gives to us from that. Okay, don't forget, this is the entire table. The entire table, let me run it out again. Um, entire table gives us this, gives us this, gives us this. We have ages ranging from 14. I think that's about the smallest. Yep, 14. We have 17. We have 20. We have 22. We have 23. We have 24. We have 27. We have 31. So those are ages. But now we have gone further to give additional instruction to SQLs. Okay, don't just go into the entire table alone. Only give us an output of students whose ages are greater than 20. Then by the time you run the code, this is a table of how many nine? Table of 9 items. It's going to search through the entire table and only select the ones that have ages greater than 20. So let's see. And this is it. So we have 22, 23, 24, 31, 27. Unlike the ones that were below 20 downward before. 14 was there, 17 was there, even 20 was there. But now we requested for something greater than 20. So I can also check here and just and just change this greater than to less than 20. So give us outputs of students that are less than 20. It will go there. So you can see we have James, whose age is 17. We have Lanre, whose age is 14. So we can play around as much as possible with data this way. Okay, let me see what else I can add to this. So let me go back to greater than 20. Yes. Now select from students uh, greater than 20. Then can I say, let's see if it's going to obey this, order it by, order by, we can order it again. There is no order. Okay, let's order. We can order it by, um, ID, and it should be descending. Let's see. Yes, select from students where age is greater than 20, order it by ID, number, and it should be in descending order. Yes. So it has gone to implement that instruction now. In the same table, go ahead and give us students whose ages are greater than 20. Then arrange that output using another column entirely. In this case, the primary column, which is the ID column. Now, in ordering it, do a descending order. meaning from largest to lowest. You can see from that column called ID, it did a descending order, the greatest to the lowest. And it now used that arrangement to answer the questions initially asked of it. So these are ways we can play around. What is it called? We can play around SQL, tell it to give us as much information as possible, and it is still very good because the language is quite very familiar or close to the human language. And when there are errors or things not correct, just like you have seen happen while I was demonstrating, you will see it and you will know that you need to figure out one or two things that need to be fixed before the code could be run. And that's how code and programming language in general is. When there is an issue, it will let you know. In fact, it will paint it red, and you know for sure that there's something you need to look into that you didn't take cognizance of before, and have to check it, then correct it. That is our computer. A computer is, of course, more accurate as long as there is nothing wrong with the algorithm written in the first class. As long as those algorithms are working fine, the rate at which processor spins and run all of those requests for execution is faster than what human brain can bear. So you will just have to go and check where the errors are and get them corrected where necessary. So we'll need to bring it gradually to a close for today. Just looking for any question or any comments before we call it a session. Check any question in the comment section. In the absence of none, then I would like to thank you for your time for today's session and see you again same time next week for next session in building our capability and familiarization with data. Thank you all for your time, and thank you